Good afternoon, everyone, and welcome to MOS Live Virtual Planetarium. My name is Christina. I'll be serving as your moderator today. And although you can see me now, you'll mostly be hearing my voice later as I share your questions and observations with our educators. In just a few moments, we will meet those educators, and they're going to be giving us a tour of space today. If you have any questions or would like to make or have a shout out today, you can go ahead and put your name and your age in our comment box with the Q&A section. Also, if you need closed captioning today, you can get those by selecting closed caption at the bottom of your screen and selecting show captions. If you happen to be watching on Facebook today, we're so happy to have you join us. Unfortunately, we cannot see your questions or observations there, but we hope you enjoy the program. Now, with all that being said, I'd like to invite our educators to turn on their cameras, introduce themselves, and get us started.
Hey everybody, my name is Talia. I use she, her pronouns, and I'm going to be doing most of the talking today, but that means I can't do the flying. I need a pilot for that.
Hi everyone, my name is Katie. My pronouns are she and her, and I'm going to be flying you through space today.
So we've talked about exoplanets on this program in the past. Exoplanets are planets in other solar systems, but we've talked about them in a very general sense. So today we're going to use a software that we haven't used before on this program to talk about some very specific exoplanet systems, which gives us the chance to get in a little more depth about how weird some of these planet systems really are. And to do that, we're using a program called NASA EYES. And we will have a link to that program at the end of the show. It is free software that you can download. It's got 3 focuses. There is one focus on Earth itself, another on our solar system, and then the third focus is on exoplanet systems. So obviously today we're going to be using the software that focuses on exoplanet systems. So Katie, let's go ahead and start off in space. So just as a beginning, look at all those shiny points. Those are all exoplanet systems. Those are all confirmed exoplanet systems. You can see there's a lot of them. This program is great. It allows you to fly around and check out systems as a whole. It lets you look at specific telescope surveys. And what we're doing, it allows you to do what we're going to do today. Oh, I love this view here. Katie is showing us that cone of exoplanets is entirely due to a single spacecraft. That is the Kepler Spacecraft and all of its discoveries in that cone shaped, because Kepler stared at one area of the sky over a long period of time and discovered a ton of exoplanets in that patch of sky, which is why you get those fun artifacts. But although Kepler is responsible for a vast majority of the confirmed planets that we currently know about, today we're actually mostly not focusing on Kepler planets. We're going to talk about planets that were discovered by a bunch of different methods. And we are going to start with, well, we're just going to start right at the beginning. It's a very good place to start. And for that, Katie, can you take us to the fantastically named PSR B1257 plus 12.
It's a lovely name.
It's gorgeous, isn't it? So here we are. We are flying to this gorgeously named system. And this one's a little different from any of the other ones we're going to talk about today. The PSR at the beginning of the name means pulsar. A pulsar is not a living star. So this graphic is a little bit deceiving because this looks like a star. A pulsar is actually the remnants of a dead star, a star that ran out of fuel and went supernova. And pulsars are specifically the cores of these stars that get left behind, and they're spinning very rapidly. So there's pulsars all over the sky. And certain astronomers like to map these pulsars. And back in 1992, an astronomer took advantage of the fact that one of our big radio telescopes, one in Puerto Rico, was actually broken and couldn't move, it couldn't point. he took advantage of that to do a survey of pulsars in the sky, because the sky was just passing over the telescope, which couldn't move, but that was great for him. It was exactly what he needed to do a pulsar survey. And he found this one pulsar. Like I said, they spin very rapidly, and their spinning is very, very, very precise. Pulsars are like the timekeepers of the universe. But he found this one pulsar whose spin was off. It had a little hitch in it. And he eventually figured out that that means something's pulling on it with gravity. And the best explanation was planets. Planets orbiting this pulsar. So Katie's pulling us back now so we can see, we now believe there are definitely 2, maybe 3 planets going around this pulsar. And these were the first ever planets discovered outside our solar system. And right off the bat, this was really weird, because this was a place that nobody ever thought to look for planets around a dead star. And in fact, we think this solar system may have something of a unique origin. These planets may not have existed before the star exploded. They may actually be built out of the remnants of the star that were drifting around after the star exploded. So this was 1992. This very cool looking solar system, very weird looking solar system is discovered, the first outside of our own. And turns out we have found a couple. I think there's at least one other pulsar that we know has planets around it. So this one is not unique, but it was very weird. So even though these were the first planets that we discovered outside of our own, it wasn't really considered proof that other solar systems, like regular solar systems like ours, really existed, because this one is nothing like ours and did not form the way ours did, we don't think. It's very, very strange looking. Little did we know it was really only our first taste of how strange solar systems can be. So that was in 1992, the very first exoplanets. And again, they're sort of they often don't get counted because they're orbiting a dead star. If you ask a lot of people when the first exoplanet was discovered, they don't say 1992, they say 1995. Because in 1995, we had another accident. Katie, can you take us to the star 51 Pegasi?
All right.
So in 1995, an astronomer who focuses specifically on stars was looking at this star, this fairly unremarkable star, 51 Pegasi. And he was looking at the spectra, which is he was splitting the light from the star up into its component pieces, like when light passes through a prism and makes a rainbow on the wall. And he noticed something about the lines that you see when you do that. They were wiggling. Stars' spectra shouldn't do that unless the star itself is wiggling. What would make a star wiggle, he wondered. And he came up with the idea, what if there's a planet pulling on it? And he had another astronomer back up this observation, and the two of them eventually won a Nobel Prize, in part because, yes, it was a planet pulling on this star. And so the nomenclature that we use for planets around other stars is we name them after their star. So the star here is 51 Pegasi, which means the planet is 51 Pegasi b. We like to call it 51 Peg B for short. And hurrah, this is it. The first planet we ever discovered going around a living star, a planet that presumably formed in a manner similar to the ones in our solar system, which meant we figured this planet would sort of conform to the patterns that we see in our solar system. You know, in our solar system, you have the small rocky worlds close in, you have the big gas giants farther out. And we assumed that would be a pattern that you would see repeated in other solar systems. This very first system around a living star shattered that. So Katie, let's go visit the planet. This is a planet that is very, very close to its star. It orbits its star in just over 4 Earth days. So that is, just to give you an idea, Mercury, which is the closest planet to our sun, orbits in, I think it's 58 Earth days. So this planet is very, very close to its star, orbits in only 4 days, and it's a gas giant. It's a gas planet that is right up close to its star. So this was the first of a new kind of planet, which if you look off to the side, you can see the words hot Jupiter. This became a new type of planet, hot Jupiters. These refer to big gas giants that we find right up close against their stars. Because it turns out, although we were a little stunned when we found this first one, what is this gas giant doing so close to its star? This is actually pretty common out in space. And for a while, these hot Jupiters were the easiest kinds of planets for us to find, because it was easiest for us to find big, massive planets close to their stars. You can see the star do the wiggle easier when the planet is really massive and really close. So for a long time, we were finding a lot of hot Jupiters. So there goes our theory that all these other solar systems would look like ours, pretty much shattered right from the beginning by this very first discovery of 51 Pegasi b in 1995. And this was our first indication that, okay, there are other stars out there that have planets. That Pulsar was not a standalone. And if this star has a planet and our sun has planets, odds are they're not alone. And of course, we've turned out to be right. It turns out planets are very, very common out there. We think they are just as common in space as stars are, and that lots of stars have planets. And some of these systems have wound up looking the way we expected a solar system to look, but a lot of them have not. And before we go and visit a couple of these fun, interesting solar systems, Christina, are there any questions I ought to answer at this point?
We do have a few questions that have come in. Let's see, we'll go with Adam, age 12, would like to know, what was the first exoplanet ever discovered, or the first one around the pulsar? It's just to clarify, is this the one that you're talking about right now?
The first exoplanets ever discovered anywhere were the ones around the pulsar PSR B 1257 plus 12, because pulsars have horrible names. 51 Pegasi b is the one we just looked at, is the first we found around a living star, because a pulsar is not a living star. It is the remnants of a dead star.
Awesome. Thank you for that clarification. And we have a question from Mahiro, age 11, who would like to know, how far away is this pulsar?
This pulsar is quite far away. It's over 2,000 light years away. So if you were moving at the speed of light, the fastest speed there is, it would take you over 2,000 years to get there. By contrast, 51 Pegasi is only about 50 light years away. So it's pretty close. So we find these exoplanets at a big variety of distances. And the one we're going to go to next is in between. It's about 250 light years away. Katie, can you take us to Kepler 16? So Kepler 16 is one of the systems discovered by the Kepler telescope. And as we approach, I want you to go ahead and notice what's different about this solar system. And when Katie, for this one, let's go ahead and run time forward a little, just so that we can see what's going on here. Does anybody notice anything different? Go ahead and put an answer in the Q&A if you notice anything, and or a question mark if you don't.
We're giving a few people a chance to get their thoughts in. We do have one joke about maybe there's Tatooine in the screen. Someone thinks maybe there's a black hole, and Caleb, age 5, says he doesn't see a star.
Well, the Tatooine joke is not far off. So Katie, let's go ahead and run time at a normal rate and zoom in and see exactly what we're looking at here. And what we are looking at here are not one, but 2 stars. And we had to be pretty far away, which is why they didn't necessarily look like stars, but there's 2 stars here. And they are Kepler 16a, capital A, and Kepler 16b, capital B. If it's a lowercase b, it's a planet. If it's a capital B, it's a star. And we used to assume that this couldn't happen, that a planet could not orbit 2 stars at once, that the gravitational effects from the 2 stars would make everything too unstable for the planet to be in a nice, stable orbit. Now, we're wrong. We've found half a dozen of these solar systems with more than 1 star. And this is one configuration we found them in, where the 2 stars orbit each other, and then the planet orbits both stars. We have found ones where the planet orbits 1 star, and then they both together are in orbit around another star. And we've even found systems with 3 stars. I think the record, there might have been, I'm not positive as I say this out loud, I think we might have found one that had 4 stars. And it was the planet was orbiting 2 of the stars, and then those 2 stars were orbiting another 2 stars. So we've found all kinds of ways that a planet can have multiple suns in its sky. And yes, the unofficial nickname for planets like this is a Tatooine. So your joke was not far off. So this was the kind of planet that we didn't think could exist. And we found, like I said, several examples of it at this point. This planet seems to be doing fine. So it is in fact in a stable orbit. And that's exciting because a lot of stars out there have companions. There's a lot of binary systems. And if they can house planets, that ups the number of planets quite a bit. So that's a planet with an interesting star system going on. Let's go visit a planet that is interesting on its own for different reasons. Katie, can you take us to GJ 504? Zooming in, this is as you can see, this star is about, it's a little under 60 light years away. And we're going to zoom in, and you might notice it doesn't look terribly remarkable. It's pretty normal. What isn't necessarily normal is its planet. Its planet has an interesting appearance to it. So Katie, can you find us GJ504b, and we'll take a look at it. It's being...
Let's try looking it up by its name.
It's being tricky to track down.
Yeah, 504b.
So this planet is a gas giant, but it's a little bit different from any gas giant we've looked at before, because as we just swing around to the planet, what do you notice about it? This is not a photo, this is an artist rendition, but it's what we actually think the planet looks like. What do you notice about it? Put it in the Q&A.
All right, we're giving folks a chance to type, Talia, and get those answers in. We have some folks looking at the colors. So some people said they noticed purples and pinks, or that it's a strange, maybe unexpected color.
Yep.
Somebody else says it looks like Jupiter. I'll leave it at that.
Exactly right. This is a weird color. This planet is mauve or magenta, depending on who's describing it. We think this is because it's still cooling off from its creation, and it's actually still glowing. The gases in its atmosphere are still glowing, which gives it this weird color that we have not observed in any other planet. This planet is pink. So they come in fun colors. They also come in fun shapes. Katie, take us to WASP 12b.
All right.
So this is another gas giant that is very, very close to its star, and that's having a very interesting effect on the planet itself. So here's the star. We're going to zip over to the planet instead. And Katie, can you fly us around it a little bit?
Whoa.
Yeah. What do you guys notice about this one?
Well, we have one person saying they love WASP 12b, so I guess they were familiar beforehand. Other folks are saying it looks like an egg. Its shape is a little off. Definitely egg shape.
So this planet is so close to its star that and it's a gas planet, which means it's not solid. And that means the gravity of the star is actually pulling on it such a way that it is not spherical. It is shaped like an egg. It's all stretched out. And in fact, maybe being slowly consumed by the star. We think there is actually a trail of gas going from the planet to the star as the star slowly pulls gas off of the planet, which means this planet is slowly being consumed by its star. So stars can have interesting effects on their planet, but let's go to, we're gonna go now to one. Katie, take us to HD 209458b.
Oh boy, that's a long one.
A lot of numbers. This is one that is also being affected by its star, but kind of the opposite way. This is another gas giant really close to its star. But whereas WASP 12b is being pulled in towards the star, it's slowly having its gas pulled in and consumed by the star. A different thing is happening in this system. Katie, can you fly us around this one a little bit? This one's losing its atmosphere. This one's star is actually pushing the atmosphere out away. There is a trail of gas coming away from this planet as its atmosphere is not pulled in towards its star, but is slowly blasted away by the light and the heat and the pressure from its star. So there's more than one way for a star to strip a planet of its atmosphere, especially if you're a big close-in gas giant, which is not us, fortunately. Now, those are some funky exoplanets. We got one with a funky color. We got one with a funky shape. We got one that's just trailing a big stream of gas behind it as it slowly loses its atmosphere. No big deal. There's one more system I really want us to visit, though. Katie, can you take us to TRAPPIST-1?
Absolutely, my favorite.
Yeah, this one got a lot of press when it was discovered for a pretty good reason. This is another one that does not fit what we thought a solar system would look like, with small rocky worlds close in, big gas giants farther out. TRAPPIST-1 is all rocky worlds. There are no gas giants in this system. And if we pull back, you can see there are 7 planets in this system, and they are all rocky. None of these are gas giants. They are orbiting what we call a red dwarf star. So that is a star that is way smaller than our sun, way dimmer, way cooler than our sun, which means that this whole solar system really is, if you were to compare it to something in our solar system, it's more like Jupiter and its moons than it is the sun and its planets in terms of size. But here's one of the really exciting things about this solar system. There's a zone around a planet that we call the habitable zone. It's the region around a planet or around a star where we think temperatures could be right, depending on other things like what the atmosphere is made of. Temperatures could be right for liquid water to exist on the surface, which is necessary for life as we know it. Katie, can you turn the habitable zone on for TRAPPIST-1? Check that out. 3 planets in the habitable zone of this star. That means 3 planets that, depending on what their atmospheres are made of, could potentially have liquid water on their surface. That's 3 planets that could potentially have the ability to harbor life as we know it. And this one's pretty close. It's only 40 light years away, which means this is a great solar system for us to try and study up close. This may be one of the first places where we figure out whether or not there actually is liquid water on the surface of a planet. So this is a lot of astronomers' favorite exoplanet system. It's got a lot of potential and it's cool looking. So that's the end of our tour of some interesting exoplanet systems. Christina, I think we have time for a few questions.
Awesome. We have a couple of questions here. Maybe I'll start with TRAPPIST since we're on it right now. Dylan, age 7, asks, can the sun of this solar system get any cooler?
It's not, I mean, it will eventually run out of fuel, but that's trillions of years in the future. These types of stars are extremely long-lived. The problem with these types of stars isn't that they're too cool, it's that they tend to flare a lot. Our sun flares occasionally. These really tiny stars flare a lot, which is not necessarily great for planets in their vicinity. So we'll find out, we hope to find out a lot more about this system and how flares affect it.
Great. And we have a question from Adam, age 12, who would like to know if we know what solar system has the most planets.
Yes. Hold on. I have that written down somewhere, I think. Do I? We do. There is a planet system that we know. I apparently don't have it written down. Oh, yes. Here we go. Kepler 90 has the most that we currently know of. It has 8 planets, like our own. So that's the current record holder for most planets known in an exoplanet system for now.
Awesome. And maybe I'll end with one last question since I'm just looking at the time here. And this will be from Hinata, age 8, who would like to know, is it possible to see GJ504b with the naked eye?
Yeah, if you know exactly where to look, yes, which I don't. That one is a fairly bright star, relatively close. It's not going to look very bright in the sky. It is probable that if you had a nice dark site, you would be able to see it with your eyes, but I don't know enough about its location to tell you how to do that. And you would only see the star, you would not see the planet.
Awesome. Well, I wanted to thank Talia and Katie for doing such an amazing show for us today. Talia and Katie, you can say goodbye now.
Bye, everybody.
Bye, everyone.
And I also wanted to thank our audience today for watching the show, making some wonderful observations and asking some great questions. I'm sorry if we weren't able to get to your question today, but we are out of time. So what I will say is if you'd like to see more shows like this or check out some of our other content, you can do that by checking out our offerings on our website at www.mos.org/mosathome. Also, if you'd like to support the museum, you can find out more information about how to do that on our website at engage.mos.org/welcome. And if you'd like to check out some of these exoplanets for yourselves using the same software, you can see the web link to that here, which is eyes.nasa.gov. I hope you all enjoyed the program, and we will see you at the next one.